Good morning, everyone. Great to see everybody here this morning, and thanks everyone for coming along to our session. My name is Nick Penston, and I'm here with my colleague Ger McMahon. And myself and Ger work with inside Enterprise Cloud Computing. It's a centralized cloud organization with inside Fidelity Investments, and our mission is to empower the next digital services for our customers. And over the next 50 minutes or so, we're hoping you can walk away with 3 key learnings. The first is when you think about accelerating that developer journey to the cloud, what are the type of focus areas you'll be really lasered in on, and type of challenges and solutions that you can apply to it. When the rubber hits the road, implementing at scale, automation, your tech stacks, what does success look like there? And finally, when you think of key enablers like culture and learning and development, what does success look like there in relation to type of solutions that you should be leaning on to really move the needle? We'll have plenty of time for questions after it, so I'd ask if you hold your questions to then. Thank you. Okay, so first a quick disclaimer. So just to put some context about before we really dive into that discussion. So many of you will be working in an organization, you're going to have many teams that are attempting to get to the cloud, public cloud, hybrid clouds, private cloud, and possibly even all 3. And you're going to be tackling those solutions possibly to the cloud yourselves. And that can rely on then different areas of value being for your customers. You know, things like security and compliance. Are you doing that holistically across your organization, or are your teams figuring this out themselves? And on top of all of that, you may have teams that are on a variety of from a team maturity. So for example, you might have some teams that are, at the starting of their journey, understanding 12-factor applications and beginning to understand Agile and lean automation. And on the other end of the scale, you're going to have teams that are already deploying to production, embracing things like DevSecOps. So when you're faced with that type of challenge, where do you start? Where's a great place to start your journey? And for us, one of the key pillars we started on was to focus on delivery excellence. And delivery excellence is the pursuit of excellence in how we do things, how we build things, and how we operate things in the cloud. And we can break this down into 3 pillars. The first is around agility excellence, and this is really about how we work. How do we get that fast feedback from our customers and turn that into value and rapidly change those experiences? From an engineering perspective, you want to create that pathway to production, that frictionless pathway in which that value can travel upon to get that value out quickly. And finally, from an operations perspective, when you're actually in the cloud, how do you operate at scale? So we're going to look at each one of these in turn, and we'll start off with the Agile excellence. So Agile excellence, again, is about getting that fast feedback from your customer, and that could be an internal or an external customer, depending on where you're working in your organization, but the concept is the same. And being able to translate that quickly through the culture that you want to enable. So what does success look like there? So one of the first key things we saw around when we were enabling this pillar was to develop an outcome-driven culture. So what that means is that often you see teams' success is we deliver this feature to the customer, we deliver this epic, we deliver these stories. But to change the conversation to the outcome in which you intended to have by delivering that feature. So for example, did you get the adoption? Did it generate the revenue which you expected? And really focus on those type of things. We want transparency, we want accountability and reliability in our team so we can make decisions very, very quickly. We want a culture to support that. We want a fast iterative stream coming from our customers based on that feedback and being able to push that out really quickly. So what type of challenges are you going to meet when you're trying to accomplish these types of outcomes? So some of the challenges, and particularly one of the first ones if you're going through a digital transformation, is Agile practices are often top of the list in a focus area. But do you subscribe the type of practices you're going to do? Are you going to say to your teams, this is how you work? Or are you going to lean more to a loosely coupled model where you're going to let those teams figure out what's best for them and their use cases and then bubble that up through your organization? When you think of transparency, it's a real enabler when it comes to developing trust in your organization, and you need trust if you want high-performing teams. How do you create that transparency between your team members, within your team, between teams, and across your organization? That can be a big, big challenge. And finally, when you think of pivoting quickly? What type of structure do you have in your organization today, and is it optimal, or do you have a lot of dependencies, and therefore it's going to take you a long time to get those feedback out to your customers? So when you're faced with these types of challenges, what are the type of things you can do to really move the dial? So we're going to talk about each one of these in turn, but in summary, one of the foundation pieces we found was you've got to build a very strong belief system across your organization and your teams. Now, a belief system is a common set of values in which your team, when inside your team, are really adhered to and across your organization. And that can vary from team to team, but there's a common thread throughout your organization in relation to it. It really is a social contract in the way you're going to work. We want to be able to make decisions quickly based on that information flow coming back from our customers. That's going to be imperative to be able to drive those experiences. And as we move the dial, we want to be able to measure where we're at and really not saturate on the measurement, be able to have our teams focus on the work that can help move certain metrics. And finally, we'll be talking about transparency. One of the key ways to do it is to apply the concept of working out loud. And let's take a look at that right now. So working out loud is around the concept of being uber transparent across your organization. And by uber transparent, it's from everything happening inside your team to what's happening across your organization. So the outputs of your retros, the outputs from your planning, how are you doing in relation to your best practices and your maturity, and then how are you accomplishing those strategic goals of your organization. So one key way we started to enable that type of culture was to really use the concept of visual radiators. And you're probably using some of these already. So for example, if you're using physical CAN boards in your office or in the digital sense, it's the same. They're a visual radiator. They generate conversation and congregation around what you're working on. But you can go beyond that to really drive the culture. So for example, think about the maturity of your practices, your engineering practice or your agile practices. Having a visual radiator to indicate the maturity and where you want to go, putting it up in your office for everyone to see and having every team do that. And again, maybe reflected in the digital world if you're distributed teams, for example, it works the same. That really generates an open culture and being able to talk out loud in relation to the type of things you need to do to move the dial. A key enabler for us also when we were really tackling this was to look at our workspace. Again, this is both in the physical sense and the digital sense. So when you think about enabling this type of culture, this collaborative and open culture, your workspace has to mirror that type of culture. So you have to have areas that you're going to be able to congregate in and openly have dialogue so people can hear these conversations. You can drive tacit knowledge through the organization, through that openness, and drive collision conversations because you're doing things in the open. It really is a critical part if you want to be successful in this area. Another key column of the outcomes was around making decisions quickly. And the key thing we focused on here was to focus on outcomes and not outputs. Again, not focused on delivering that feature to your customer, but focus on the outcome we wanted to achieve by delivering that in the first place. And to drive this type of culture, one of the key things we looked at to help really ignite it was to use the concept of objective key results. So OKRs. They've been around for quite a while, but they're really, really powerful. So for example, and I'm in a team and I want to make a decision. How do I ensure that I can make that decision quickly? OKRs allow us to do that because the objective is something that we are aspiring to achieve, but it's not necessarily impossible. And it creates these guardrails for me as an engineer to be able to make those decisions. I don't have to go through a big decision matrix to understand it. I'm empowered to make that decision because I understand where I'm going from an organizational perspective. It also had another consequence in relation to driving the data-driven mindset. So we want our engineers, we want our teams to focus on using data to make decisions, and OKRs really helped enable that because they're data-driven themselves. Again, it was able to focus on moving the needle and rolling that up to the strategic goals of our business unit. In relation to OKRs, one of the things we focused on was one metric that mattered, OMTM. You might have heard of that concept before. So instead of saturating our teams with all this data and all these metrics, we focused on one or two and moved the needle in relation to these metrics. And as we matured, we changed them. So on to the second pillar, engineering excellence. This is symbiotic to the output of the agility pillar. It really capitalizes on now that flow of information and the culture we've built to pivot quickly. It's about the mastery of software engineering to enable us to have reliable software to support that goal. So what does success look like? So from an engineering perspective, again, we want to have a fast cadence of value. So we want, obviously, things like automation are going to play a huge part there. We want to apply the dry concept to our engineering. So we don't want to repeat ourselves. We want to have a culture of reusability. So when we think about resiliency, high quality, security, they're all a given in relation to the type of outcomes from an engineering perspective. And often one that is often overlooked is we want to develop world-class talent by focusing in this area to be able to support the next generation technologies, which are going to support the next generation experiences. So what type of challenges you might meet in relation to the engineering pillar? So I'm sure everybody in this room is working on some product that has multiple components, multiple APIs, and there might be multiple teams involved in that delivery of that product. Now, if you are inconsistent around how you deliver quality from a team perspective or security or the consumability of those components, your customers are going to reflect that in their experience, and that's something that you don't want. But how do you drive consistency? Are you going to standardize? Are you going to mandate the type of frameworks, the tech stacks? Or are you going to allow the teams to figure this out for themselves and really just focus on the outcome? And that transition or finding that balance can be a challenge. When you think of the skills and the knowledge in which you need to really focus on this area, do you have them? Or are you going to have to focus on something like L&D? And Jer's going to talk a little bit more about that. And finally, do you have the support in your organization that engineering is a first-class citizen? If not, are you going to have to socialize this and really drum up that support, because it's critical that you have wide support from a senior perspective to really make this successful. So what did we do to alleviate some of these challenges? One of the big things we really focused on was codifying that experience for the developers. So by codifying that experience, it's all those best practices, all the standards, and we want to really have our engineers embrace, and the emerging technologies, we codify them to enable them to innovate on top of. So what does that look like? We have a project called Devto. It was inspired by the open source JHipster and the Initializer project in Spring, and really builds on those concepts. And it allows the developer to deploy a fully functional API to several targets within a couple of minutes. That's really, really powerful. And it's not just a bog standard boot app. This is a fully production ready. So when we think of that end-to-end experience, the pipeline, for example, all the checks and balances already in place. When you think of techniques around testing, already in place, the things we really want to promote. Think about good practice on deployment, zero downtime deployment on several targets, already kicked into this project. From the operational side, think of alerting and monitoring. When you want to embrace DevOps or DevSecOps practices, this is obviously paramount, already baked into this project. This is all ready for the developer straight away. And we've layered on a CLI on top of this to enable the developer to really tailor that experience for their use case. Now, another consequence of us really framing the problem this way was to help us mature our testing, our quality corridor. Now, of course, you got to focus on the traditional pyramid, your unit testing, acceptance testing, and so on and so forth, and driving effective testing, not just doing the test, but having effective tests in that area. But we went beyond that. We wanted to introduce emerging concepts to really help drive the maturity of our engineering. So, for example, consumer-driven contracts. If you're using Spring, you're probably using Spring Contract there, introducing that in a very easy and consumable way. Test-driven documentation. So if you're looking at things like Spring RESTdoc, for example, enabled us to have consistency, not just in our documentation, but embed that testing methodology into their documentation. Extremely powerful and packaged in this project. But again, we've gone beyond that. Again, things like chaos testing, putting the foundation to develop the maturity in that discipline. If you want to build reliable and scalable apps, chaos is definitely something you want to be doing. So synthetic testing and continuous validation round off that quality corridor. And this really helped us drive that maturity in this space. Another key enabler was to really push and shift left from the developer's perspective. Often what happens is engineers over-rely on your CI system for feedback. So you got to commit your code, you got to wait for your build system to do it. If you want to deploy thousands of times a day across your project, that's going to be very difficult at scale. So we were trying to push everything left onto the desktop. So using, when you think of things like Kubernetes, and we've heard lots of great things around this, scaffold and so on and so forth, using those type of techniques to be able to get the developer to get feedback straight away. Now, another consequence of this was when we wanted to really introduce small batch size. So we want to be deploying continuously to production throughout the day. That really helped initiate that type of concept. And when we were moving towards trunk-based development, for example, this was a key enabler when this was in place. And again, much like the Agile, we wanted our developers to be data focused. We wanted them to use data to improve their engineering maturity. So of course, you got to focus on things like your code quality, your security quality, they're a given. But we wanted developers to really own that process. We talked about an outcome of having that continuous value stream to the partner or to your customer. And for example, when we looked at lead time in relation to commit to production, the engineers own that problem. And they have the data to solve that problem so they can start optimizing their pipelines to really optimize how fast we can get that value out. So looking towards minutes rather than hours. So finally on to the operational pillar. And this again builds on the previous two. This is about applying best practices in operations of applications and being very customer focused in this domain. So what type of outcomes were we trying to achieve in this area? The first is when we think about alerting and monitoring, and anyone who's been doing this for any length of time will know it can be quite difficult to understand what to monitor. We want to be very customer focused here. So anything that was happening, we wanted to alert on the customer experience, not necessarily the lower level data which wasn't affecting them. We wanted, if we had an issue, our time to repair need to be minimized. So our detection time and that lead time, which I talked about in engineering, we wanted to keep that tight so we can push those changes out very, very quickly. And again, we want to enable resiliency and reliability through the operational pillar. Now, as we tackled some of these outcomes, one thing kept coming up over and over across our teams. And it really was, as we embraced telemetry and all sorts of logging techniques and tracing, etc., we started to find a lot of noise across our systems. So think of your developers. They're enthusiastic about using things like Spring Micrometer. They're pushing all this data out, and they're starting to alert on virtually everything, right? So now their pages are going off continuously. In the middle of the night, you're going to have a lot of tired developers every day. So what we needed to focus on was, what do you really measure when you have that type of leverage in relation to the data? And that kind of brings us on to the challenges in which we overcame. So the first one was to apply SLO and SLI concepts. So service level objectives and service level indicators were great ways for us to focus on the customer experience and the impact our systems were having on them and react to them as a priority versus things that ultimately needed attention but weren't impacting our customers. And then codifying that experience. I mentioned in the Ditto project, the operational side. The Ditto project comes with SLOs and SLIs already pre-baked and the best practices we see around those areas for those APIs, for example. When you think of the resiliency aspect, talked about it on the engineering side, introducing those concepts, creating that capability. On the infrastructure side, be able to create that minimum requirement for applications. So every application must be able to withstand certain events before they come onto the platform. So creating that kind of contract and using chaos engineering to verify them. And finally, one of the biggest shifts around the culture was to utilize blameless postmortem. So when we do have issues, to be open about those issues and in the spirit of working out loud, to be able to discuss them and have actionable items that are immediately executed on to continuously improve. Now, over the last 3 pillars, there's been 2 common themes, and you may have noticed them. The first was around the customer focus. All through the agility, the engineering, and through the operations, we were really lasered in on bringing that back to the customer. The other was around codifying that experience to create a foundational acceleration for our engineers to not just leverage best practices, but to get those applications out quicker. And the reason for this is we want our engineers to focus above the value line. Above the value line is where you're adding value all the time to your customers. Below the value line is ultimately tasks where are not having direct benefit to your customers. And across those three pillars, we were laser focused on ensuring everything the developer was doing was above that gray and white line. Now, one area we did see that used to dip into that gray line was around automation, that end-to-end pathway to production. So what did we do to overcome that challenge? Was to look at a couple of different pipeline strategies, and I'll talk about two here. The first is when you have those teams on the lower end of maturity. They're only beginning that journey. You know, as I said, they're only starting to understand 12-factor. They're, starting to go on their Agile journey. How can you help those type of teams accelerate to the cloud and really help your adoption? And one way to do that is to be opinionated. And being opinionated means you're providing that pipeline, that end-to-end experience for that application to travel on, and they can focus on their application development, 12-factor, and building those amazing experiences for your customers. So what does that look like? So as you can see on the green is a pipeline, an arbitrary pipeline. Plenty of things we could add to it, but hopefully it gives the idea. So the green part is what the application team focuses on. They're focused on application development and testing their application verification. You supplied the rest. So all the checks and balances you're expecting that application to go through, you're supplied it, and they're going to put that application on that runway, and it's going to push it to the cloud. Now there's a couple of key outcomes result from this. First, it's going to help you accelerate that adoption. They're going to focus on application development, not the complexities of getting to the cloud. So that's going to really drive that adoption for those teams and really help them in learn about application development. It's going to remove that complexity. Again, metrics are going to be important. Everyone wants to, in digital transformation, to measure that adoption. If you've that end-to-end, you want that end-to-end experience, you're going to be able to measure that adoption very, very easily. And again, in the spirit of dry, it can be reused across your organization. And again, you're writing it once and used by many application teams. But there is some challenges. This really works well from a narrow cohort in relation to the target and the type of patterns you're applying to. Anything outside this, and if you expand the amount of targets and the amount of web patterns, you're going to have to maintain many, many connection points, and that's going to be an extremely lot of engineering effort. But you're also removing flexibility from your team. So as they are starting their journey, that might be okay, but as they move along that maturity curve, how do you introduce and allow them to mature and add into that pipeline is a big challenge. But what about those on the other end of the scale? Teams are already deploying into production. They're already in the cloud. How do you help them accelerate? And one way to do this is to change the rhetoric slightly and to focus on enabling key capabilities which you as an organization need across all your teams. And a good example there might be around security. And the level may differ, but really it's a good example. So for example, you want to have consistent and holistic security policies being applied to all your workloads going to the cloud. So what does that look like? So in this case, you see that there's a lot more green in relation to your development team because they've already built this pipeline. The gray boxes, and in this example it's on the security area, is a detective control or preemptive control that you're putting in the pipeline around some of that security area. And in reality, there's going to be a bit of a blend between detective and preemptive controls, and Jer will touch on this in a little bit after. But essentially what you're doing is you're enabling those teams with the capabilities you care about and not being intrusive into the way they work. But it does create a couple of challenges. First is the integration of, you're going to have a wide amount of workloads to contend with, unlike the previous strategy. And therefore, those capabilities are going to have to cater for those. And then put that across multiple cloud, and that gets even more complicated. From an end-to-end perspective, you don't want to be intrusive. These teams are already deploying to the cloud or already going quickly. You do not want to slow them down by applying these principles on top of them. So again, you need to ensure that that is the case. And in the case of the security use case, these teams are deploying to the cloud. You may want to be able to say that all these workloads need to go through these checks and balances, and how do you actually know that it's happening in their use case? And that can be very difficult, and especially in a multi-cloud issue. So I'm going to hand it over to Jer now. He's going to talk about accelerating and the things that we've done to really scale out some of that automation.
Thanks very much, Nick. Yeah, so what Nick's brought us through is like, so in Fidelity, we've about 15,000 technologists. We have in and around 3,000 to 4,000 teams. So these are separate application teams that are building, different application products, whether it's microservices or mainframes, monoliths, and everything. So when we've been, we're a center organization trying to enable cloud so how do we help all of our teams in Fidelity to get to the cloud, and how can we make that easy? How do we make it very frictionless? But when you have 15,000 people working in technology, it can be very complex. You get, everybody's can be doing the same thing. So from an ROI perspective or from a budgeting perspective, the cost, gets astronomical. So, we're going to cloud to try and lower costs, faster time to market. But if you're actually spending a hell of a lot more money to get there, it's not a very good story. So in our team, we've brought through our journey of what, services and things we're building and how we're getting to the cloud. But our thing is now, how do you scale that? Right, so how do I take that, what Nick's just talked about, and how do I give that to 15,000 people who might not agree with you personally, or might have different, political belief systems, or how dare you? I want to use this language, that language, this technology stack, or another technology stack. But the one consistent we found was with manual deployments, because we're heavily regulated, so we have a lot of compliance, we got a lot of security, we got a lot of audit, and we have different types of applications. So we've got internal applications, which are pretty lightweight and free, all the way to SOC, HIPAA-based applications, which have a different set of, policies and controls that they need to be gated before they can actually run in the cloud. And essentially, not all the cloud's available to them. So how did they know this? So automation. So manual is not going to work. So how do you automate everything, but how do you automate that at scale? So when we build software applications, everyone's, we heard about Spring Boot, we got Kubernetes now. We saw the pretty interesting demo yesterday of Spring Cloud on Azure, and how quickly Cosmos DB can be just added to an application and distributed across the globe. So, there's a huge amount of innovation and stuff gone into cloud, into services, but how do we take all of that innovation, all those best practices that we use in building applications, and how can we bring that into the automation side of the house, right? So traditionally, automation might have been built, there were bash scripts, shell scripting, they were embedded in tools, there were code snippets. So we decided to be bold, and we set ourselves a mission that says, I want to be able to deploy to production 10,000 times a day. Right. So if I want to be able to achieve that level of deployment, it's probably impossible unless we're coding really smallly. But what do I need? How do I need to rethink about everything in order to achieve that? So by thinking big, we actually had to strip back and say, okay, well, everything we know today and how we've done things in the past actually has to go away, and we have actually to reinvent how we do pipelines, how we do automation to support that. We wanted to set out a set of outcomes and how we could essentially, keep track of what we were doing. So obviously it has to be very high performance, and not only for our own applications. If I'm going to try and deploy X times a day, X times a minute, and I've got 1,000 other applications trying to do the same things, how can that scale horizontally and vertically across it? So for example, traditionally I worked in a team and we were building a portfolio management system, and our functional regression test took 8 hours. It's very, very, very comprehensive. However, that's, you're maxing out at one deployment a day here in that type of thing. So how do we iterate? How do we get faster at doing things? Everything had to be testable. So if you're going that fast, everything has to be automated, and the quality of it has to be really, really, really reliable. It cannot be, and if it is not, if you're putting anything into production, how do you know it is actually working? So again, even in production, we, concept of continuous verification, to verify that my application's healthy, the behaviors of it it's behaving as expected, etc. scripting won't work, right? Bash, so we wanted to see where we could take modern software architecture, modern, design patterns, programming languages, platforms, etc. How could we use them in our automation and in the pipelines to enable teams, and we could tap into the benefits and the innovations that those things provide. Observability, Nick talked about, the working out loud, the SLOs, the SLIs, all of these things. You have to be able to look into your system. You have to be able to see the data, because if you don't understand what your system is doing, you have actually no idea how to improve it. So what we're trying to is and this is including our pipeline. So when you start a pipeline, how long does it take to run? What are all the individual stages in the pipeline? How are all they behaving? Is one slowing down as the other? Is it very large? We had someone say my pipeline is slow, and the first thing they did was try to download a 10 gig Docker image as part of it, and I go, go figure. But unless you have that level of insight into what's going on, and from a platform perspective and a pipeline perspective, you don't get it. And the last thing is reuse. Yesterday we heard about culture and people, but if we're a team of 12 or 20 or 30, doesn't matter, pick a number. If I got 15,000 technologists, we can scale a hell of a lot faster. We can create more capabilities and much quicker, and we can actually get better and better over time, rather than one team doing everything. So where did we start? So we've been doing this, I think we met Kelly in the Concourse team a couple of years ago, and so we've been at this about 2 years. And this is where we started. Traditional scripting, it gets out of the blocks really, really quickly. So you can actually start really fast. You can actually make a lot of progress very quickly. However, you suddenly run into roadblocks or challenges very, very quickly. The more if it's a simple one, it works beautifully. You start adding complex applications, you start bringing dependency management into it, it starts falling apart and breaking. And then the scripts don't scale. There's no software delivery lifecycle that you can put around these scripts. So you're trying to store them maybe in your Git repo. You're copying and pasting them out of that into something else, and it's hard. It's very opinionated. So here it is. If you want to use it, you use it. If you don't like any part of it, you get nothing. And debugging it, now you're starting to go in and you're starting to add print lines and, running again to try and determine what again. And again, all of this is slowing you down. So what we're finding, while you got out of the blocks very fastly, suddenly our pace dropped. So what next? So we said, okay, well, that's not going to really get us to where we want to get to. So we said, okay, if we use the concept that an application is an artifact, can we apply that same thing to our pipeline automation? So we created a concept of shared library. So this was a big monolithic library that grew and grew and grew and grew. We deployed it onto the orchestrator. So whatever orchestrator you were choosing, it was physically installed onto that. Again, worked nicely. We were getting fast feedback. We were able to run these things. We were getting a software delivery lifecycle. We were able to have an SDLC process around it, how we could run it. We could actually test it to an extent. First one, brilliant, lovely. Second one, yeah. Third one, not so much. Fourth one, oh, now we had all of these running on the orchestrators. Now customers were using this, and we were finding, okay, well, I'm happy with mine. Well, now I've got version 2, I got version 3, I got version 4. How do I manage the technology lifecycle of this thing? I can't remove it because there's people using it. If you don't have a great amount of observability into who's using everything, then you can't remove it, because you don't know if you pull that off the orchestrator, then people's pipelines just start breaking. And then the complexity of releasing that, so on backward compatibility. So you have to release everything together and then upgrade everything regardless, and then you have to test everything. So over time, again, our velocity of delivery actually started slowing down, because we spent more and more time was going into the build, the deploy, the release process than actually was going into the development process. Next, the 2.0 version of the shared library is, I talked earlier about trying to borrow off application developments and best practices, microservices. So microservice paradigm, if you think of it as a design pattern, can be applied to pretty much anything. So taking a microservice approach, we said, okay, can we break these into modules? So now we can build module, deploy module by module by module. We're now really fast at delivering any new capability. So we can code, we can build a capability, we can package it up in the module, we can get it out there. Teams could actually contribute to this model, right? So we could have a repo, we could have different modules in that repo, or we could have multiple repos building into one combined. So with a lot of people actually able to add into this, they could copy one existing one, add a new capability, run a build deploy, and off it goes. Performance of these things was much, much better because now they were much smaller, much more lighter weight. And again, you were in control of that because it was just a thing. Versioning was good for the individual things. However, over time, as we got more and more of these, we see the challenges with microservices today, like ITSIO, service mesh. They're all coming now because of the complexity of managing your application ecosystem or what at scale when there's a lot of vendors. How do you know what's going on? When you're using modules like in Python and deployable things that might be running on an orchestrator, how do you manage those dependencies? There's no real tooling or technology, dependency management between one version and another version of everything. So suddenly the sprawl of these things, the amount of them we had in the systems actually started to break down pretty quickly. And again, with any of these first three processes, the ways we were doing it, we were actually tied to the orchestrator. So, technology is changing at such a fast pace these days that we didn't really want to be tied to an orchestrator, or if somebody else already had an existing orchestrator, if they use another tool or another technology, then, how good to get to use your, stuff from the center to use it in their applications, because the effort for them to jump from what they had today to what you had then was too difficult. So, APIs. So, there's a revolution around APIs. I think we're seeing the Spring Gateway being released here. API management systems. You got Amazon's AWS with their gateways. So an API APIs Spring Boot. So if we write Spring Boot applications, we have the data framework. We can actually print an API, and we can actually have an API running in production with business logic in 24 hours from start to finish. It mightn't have everything, but we can actually release it in 24 hours. Starting with the Ditto framework, and we can take all the advantages of what our friends here at Pivotal are doing with it as a Spring Front and Spring Boot. We can take advantages of if you're running it on a Kubernetes platform, whatever distribution you want to use. If you're running the cloud service providers, you can actually now start deploying there. And even more beautiful, you can actually run it from your laptop, right? So I can actually have all of these capabilities as APIs. I can just run a curl command off my laptop from within my repo, and I can actually now start accessing that. So Nick talked about how do I shift left, how do I go local. This enables us bring any of these things so far left into the software delivery lifecycle that we've really found that it's sped up development by a huge magnitude. Because one of the other feedbacks of the previous three processes was that you were finding your feedback at deployment time. It's very frustrating for a developer or an application team to discover right as they go press that magic button to get the prod that there's an issue, right? We're still not there from a process perspective and change management, so they've gone through all of this hard and heavy lifting to get there, and then suddenly to find that there's something wrong. So by pushing all that as far as left, they can run these things locally now, discover all of that, run their CI processes, and again, be baking these APIs into that. And then from a quality perspective, we're in a much better place to release higher quality capabilities because now we got APIs. Nick talked about all the different Spring, libraries we might use there, the other mock frameworks that we can test it. So again, the reliability, the testability, the resiliency of it is if you deploy these on a modern platforms, you get all the benefits of the modern platforms, again, all free and out of the box. So again, it really has helped us get there. Which brings me to, and the thing is with here, this opens doors, right? We see today, we saw yesterday and today the new announcements that are coming from Pivotal. You've got Ignite coming up, you got CNC at KubeCon coming up in November, you got reInvent coming up in December. So over the next couple of months, we're going to see a huge amount of announcements of new things that are coming to make our lives so much better. However, it's actually trying to keep up with it is actually going to be the problem. But by having modern software applications using modern platforms, it opens the doors for you to take advantage of the opportunities that they can give to you, and it's up to us then to figure out how do we apply those in the jobs that we want to do. Does come with a couple of things that we have to watch out to, and what we've seen is the faster we get to go and the more we open the doors, the more stuff that people get access. So it's like technology playgrounds, the amount of technologies, the amount of programming languages, the amount of frameworks, the amount of cloud services. Do you go hybrid? Do you go native? Do you want to be agnostic? Do you want to be portable? Do you want to be locked in? So there's so much information there. The innovation that's happening out there right now is bringing in that it can actually be overwhelming for teams, and that can actually start slowing you down. So from a technology stack perspective, we have our data framework. It's built in Spring. When we call it a framework because we have a Spring version. No reason we can't have a Python version. There's no reason why we can't have a TypeScript or JavaScript version. There's no reason we can't have a Go, right? It's a way to build and develop, build, package, test, deploy, and operate your software, and what it gives you. And if you want to do that for one technology or another language, again, what you want to do is commoditize below the line. But it allows us to create technology stacks that we can kind of standardize on, but with flexibility. Because if everybody's saying, well, I'm just going to build a Go one, I'm going to go. Go is already there, Spring Boot's there. Okay, I'm going to pick Python. The amount of time to build all of that is below what we call below the line, as Nick referenced to earlier. However, you cannot be too prescriptive or too opinionated, because how then do you innovate? How do you get your teams innovating? Because then now you don't have a great culture in your organization or your development teams. Your developers go, well, you're not letting me do my job. You're not letting me experiment. You're not letting me learn. So we've created what we're calling enterprise blueprints as a kind of a framework in which we can provide standardization and consistency, but flexibility to allow people operate and innovate. It also encompasses the process of, as new things come in, how do we ensure that they get brought into Blueprint, but we can focus on the below the line and actually integrate it into our ecosystem. As we're Fidelity and we're in a very regularized industry, security, any time you see an announcement in the papers or in Wall Street Journal, it scares companies, in the financial services. So the big thing we're trying to do is we want to build the security and the safety into the automation, so developers don't have to worry about it. So we can actually continue to maintain the velocity or even increase the velocity, and that's going to help us scale to where we need to get to. Quickly touching these, I mentioned it earlier that we had modern application development. So we think this has really been the critical and core to how we've been able to accelerate teams and how we've been able to move the dial very, very quickly. So when we talk about modern applications, architectures, platform security, Kubernetes allows us to observe the running state of your application, and if it gets out of sync or it's not synchronized with your declared state, it can actually auto remediate your application, right? So Spring config is another option where you look, says you change your config, you make a commit, suddenly your application's refreshing itself and it's updating. So these things provide you much more hooks and much more capabilities that you can actually get, figure out how to bring all this automation in more and more, and the developers do not need to write it. And here's the security, right? So Nick, I think, mentioned a couple of them earlier, but we've divided up into 3 separate sections. So defensive, preventative, and detective, and we're looking to automate. So we're going to try and automate all of these. The complexity in the security and getting to the cloud, is if every team has to go through that, you will actually run out of humans, right? You would actually have a cybersecurity group that's the size of actually a very large country. Never mind, and then again, you don't scale, right? Everything stops and everything slows down. And if there's any exposures, any risks or vulnerability brought into the system, you really have to start all over again. So we constantly see, vulnerabilities being discovered years after a library or a framework has been out in industry and been used. So, how do you know what you have running out in anywhere if you don't actually have information around what's in your applications? When we ran in our data centers, you have 4 walls, you have a big firewall around it to protect it. So as a developer, you get security for free, right? Unless you're building an external facing application, but even then, you're between your networking, your security groups, you got your DMZs, and you've got all your controls that are provided by that for you, and you just got to get your application in there. So how do we do this? So in the defensive side, so we are enabling scanning, right? So scanning at where you bring in. So if you run Maven, you run NPM, it's going to suck down a lot of dependencies. We're actually proxying all that through a central repository, so we can actually scan every library and every framework that comes into the system. Once it's down, once the first person is downloaded, that's then available to the next person to come for free, right? So you get a latency on your first download. Everyone else benefits from after that. So we can run a bunch of defensive controls. So when you're starting your development and you're still in your IDE here, you actually get security built in off the bat. If we discover any vulnerability in any library or any framework that we want to use, then we can actually just move them out, and actually you'll get a notification back in your system. Nick showed the diagram of our compliance gates or of deployments, and we have preventative controls that will actually stop the deployment. So we have non-negotiable security policies. We have probably ones that are negotiable. So we can actually have like red and orange type alerting on, as you're pushing something through. If anything in your code is in violation of any of the controls or policies we have or the rules we have, we can actually, and if it's a red one, we actually stop the build. So we actually will not allow you into production. And that's why we want to shift, when we put these into APIs, we were able to shift this back to the IDE so people actually could test this out before they ever started even their CI and CD. And then detective, right? So things get into production, they're running, things can go wrong at a later point in time. If you're using AWS, you can someone can do a VPC peering to you, and suddenly the topology of your application, the infrastructure your application runs on, there's a fundamental change to that's not necessarily something caused by you, but how do you know? If there's a vulnerability provided into if an AMI is got a vulnerability into it, and we've seen some of them with Amazon in the past, and we've seen zero-day ones where they've been patched within 24 hours. How do you know what's running out there? So we're actually focusing a lot with our detective controls on operation and in production workloads. So we can scan, we can look, we can report, and ultimately over time, we want to actually have intelligent remediation. So if you want to rehydrate, why can't actually we have something in a detective control launches some automation that actually can rehydrate your, whatever you're running. And why do we do all this? Right, so we get to do some of the cool stuff, but why are we doing this? So we're doing it because it's technology and innovation from our perspective is to drive and enable the business. Right, so that's the core thing we're trying to do, is above the line, is its sole purpose here is to enable our business. If we have technology playgrounds, we're not enabling our business. If you're using technology for the sake of technology, you're not enabling the business. If you're not focusing on the organizational needs, again, we're not focusing on the business. Is it just a POC, or are you just experimenting? Owning the cost, we're actually providing full we're automating it, I think, pretty close now. So full visibility into your cloud, into your application costs. So what does your application cost to run in the cloud, and providing you that feedback automated. So actually, in time, we could actually, if an application starts running away from a cost, we could actually put automation around it. But there has to be balance, right? You can't have a very prescriptive, narrow environment where it's completely, the technology is regulated from a center group. It just doesn't work. So we have to figure out that right balance. And Nick talked about the culture earlier, is we want to get people in doing the right thing. And we want people doing it for, what is right, and not necessarily, being biased to their preference or biased to some notion that they may have, and they're just picking the technology, which is actually just a confirmation of that. Because in our early days with in cloud, when we say we didn't necessarily have the level of automation, or we didn't have the level of controls and checks we had, essentially we just got into technology sprawl. We just literally opened the doors of Amazon and said, 4,000 people, off you go. We were using every database, every database. I think someone ran a report and we used every single database in Amazon, managed all the way from Aurora to managed Aurora, MySQL, and Postgres. We used all the versions of RDS. We actually had Oracle and EC2. Someone wanted to run their own databases on EC2. So we had everything. That creates a huge amount of complexity in the system, right? How do you even monitor that? How do you have centralized governance? How do you, anything like that? And just like urban sprawl makes travel less efficient in our cities, technology sprawl makes it a lot more, speed of delivery is less efficient. So when Nick talked about the SLOs and SLIs, from our monitoring, so we actually have centralized monitoring. We actually have automated dashboards of that monitoring. So we're able to go through all of that, and they get all of that for free. Because this is developers' heaven, or if you're in Ireland, this is the pub at 12 o'clock at midnight, and where we do all our greatest stuff, right? But, we don't want to be here, right? Imagine if your business partners or your finance saw this, right? It's not a good place to be. So it's not a technology problem. It is really, really, really a people problem. And that's why we want to focus on the culture. So the culture is hugely important. We're doing the culture because we want to increase speed and agility. We want to create a culture of ownership within the teams that own their applications, that are responsible to their applications, are responsible to their business. And we want them innovating. We do definitely want them innovating, and we want them to innovate to increase value, not for complexity or sprawl. So again, how are we doing this? So again, Nick talked about it earlier, delighting your customers. So we want to innovate, start with our customers, and ultimately delight our customers. We want to remove obstacles that slow down releasing products. So if I want to do 10,000 builds a day, where are the things in there that slow me down? And then we want to live and breathe innovation. We talked about our delivery excellence and our agility excellence. We want to have the innovation across all of the three pillars. However, it's tough. Innovating is tiring. When you get the time to innovate, we've tried it with innovation days. We actually have innovation hours in our sprints. Sometimes people were never completing their innovations, so they were getting frustrated because we're innovating for a day or two, getting so far with something and an idea, and then coming back 3 months later at another innovation day to complete it or working it again. And it just got tired of it. The first one was super, second one less so, third one, people stopped turning up. So where next? So how do you get to, so I'm a big Formula 1 fan, so in 1952, a pit stop took over a minute. They've now got a pit stop down to, I think it's 2.6 seconds. So everybody's innovating. So you have to figure out when you're innovating is where do you want to innovate, right? What is the key blocker? Where is your performance bottleneck? And the only way you can do this is keep learning. So keep learning from a technology perspective, keep learning about your actual systems. And this is where observability comes in. If you don't have an observable system, you can't actually learn about your system. So we want to, keep learning across everything, right? And how we're doing it is it's creating a culture of learning and improving. So I think if you looked, I think there's a learning pyramid, and it talks about that the bottom two sections of it, if you learn by doing, you have a retention rate of 75%. If you learn by teaching, you have a retention rate of 90%. So what we've tried to construct is, you can go onto Udemy, you can watch YouTube and stuff, but the retention rate and how you use that, it can be low. So we've set up engineering, software engineering excellence program, where it's all hands-on. It's actually taught by the associates themselves. So two ways: you get pair programming, you get learning by doing, you get learning by teaching. So we're constantly building the knowledge of everybody in the organization. Everything's contextualized to us. So you can go learn Amazon. Amazon in your company might be very different than the generic Amazon. So how do you actually contextualize your organization and your automation on top of that? Codeathons and learning days. So learning days is something we're looking at, that we can bring a learning day into every sprint. So you get a day every 2 weeks to learn. How you learn over that sprint, but this is the way we think we can sustain the learning and sustain the improvement over time. But it does come with challenges, and this is where I think the learning days is where we think we might have hit a sweet spot. How much do you do in the office versus how much do you at home, right? I personally don't believe it's enough to do it in the office. I don't think there's enough time. There's too much. But there is a balance. You can't ask everybody to go home and learn on the weekends and the nights as well. So you have to get to find that right work-life balance. There's so much out there. Like, where do you start? We actually had feedback from a lot of people going, I don't know what to do. You point to me, Udemy, Pluralsight, Linux Academy, the internet, and they just come back and go, I don't know. So we're looking at trying to create things like learning paths. So I want to learn Kubernetes. Okay, great. Here's a learning path. And we're actually using ourselves to curate those paths. So if somebody has gone and taken a course or taken a lab or a workshop, they can actually contribute that into the path. So actually the next person that comes around says, oh, I want to learn this. And here's actually a path of learning. And we're just using all the content. And again, it's learning with a purpose. Because if you don't apply that learning, is it any good? And I think there's a retention curve out there from, I think, some German psychologist that shows that if you don't use something in 30 odd days, you actually forget what that is, right? You'd have to re-go learn again. We want to make sure when we're learning, it's just in time and we have that context. So just to wrap it all up, right? I think someone said it yesterday, it's all about the people. At the end of the keynote, it is all about the people. If you don't invest in the people and we don't work in developing the people, it kind of all breaks down. But you do need to transform your processes and your technology in support of that. So the people have to transform the processes as well as the technology. One without the other doesn't work. You got to continuously improve. It just goes, it's next sprint, and it's a journey. It doesn't ever end. And feedback's the only way you get to learn of how well you're doing. Is the learning? We've tried a lot of things. The feedback helps us take the next iteration of the improvements what we want to do. So it is a constant cycle, and we constantly work on this. Every sprint or every what we call program increments in groups of sprints, and we keep reassessing that every time so we can build on top of it and try new things and hopefully make it get better. So just want to say thank you very much for your time and attending the talk, and myself and Nick will be outside if anybody wants to have any questions or talk to us afterwards. Thank you.